Hello everybody, Chaz Large here once again with another little video for you. This time not a repair, bit of a modification video. And if we have a look at what we've got on the bench, we have got what's known as a sound bomb. This is basically a portable speaker. It runs off batteries, standard AA batteries with a power switch, and in the top here we've got a 3.5mm jack plug to plug into an audio source. That's it. That's basically all it is. I picked this up with a bunch of other speaker units and sound bars and all that sort of stuff in a bit of a job lot, and I thought, well, it's okay. I tested it out and it's actually got quite a good sound to it. But obviously, being just a portable speaker, nobody wants just a portable speaker these days. What they want is Bluetooth. So I thought, can I modify this to have Bluetooth? Well, luckily I managed to find some bits and pieces on the internet that allows me to modify this to put Bluetooth in. So let me show you what I found on eBay. Let's have a little look at this. And basically what it is a bunch of modules that are available. You can get them, and they sell them straight from China. Here you can see they sell them straight from China, but if you search for the same sort of thing, you'll find these modules available from Chinese sellers that are based in the UK. So obviously some brought stocks over, depending on sales. And there's three different modules that they have. There's the smallest one, which is the M18, then the M28, which has got sockets for audio input, and also micro USB for charging, and or for power, and this one has got charging facility to charge up a battery as well. Now if we have a look at the actual circuit for this, it's very simple. Basically the circuit to use this is quite simple. This is the module, and it's basically got these connections, so one for the keys, one for muting, one for supply, one for ground, and one for left and right output. So this is the module that I've chosen, the very simplest of all. And there you can see this is basically an amplifier that you would connect it to. So once it's powered up, it goes straight into Bluetooth receive mode. You connect it to your output device, like your phone or your tablet, whatever, your computer. And then the output from this you would then take into your amplifier. So basically where it says amplifier, the Chinese writing, that's basically going to be my sound bomb, and hopefully the supply on that is going to be sufficient. We should be able to get all that in there. There's quite a bit of space. I've already had this open when I bought it originally, just to check it and test it. I've already tested the module. Basically hung some wires in. Let me just show you with the hang on, let's get rid of the web browser over the top. Basically I've already wired this up, so we've got the connections. They're all quite easily labeled: key, mute, supply, ground, left and right. I've tagged onto this a 3.5mm jack, and then taken that out to my test amplifier, and that works fine with a supply of 3.7 volts, because this one is designed to work with either a lithium ion battery or just straightforward batteries, or about anywhere between 3.7 and 5 volts. Now the batteries that are that go in here are, I think there's 4 1.5 volt cells. That makes 6 volts. So I may now need to step down the supply a little bit to make it work with this, but that's no great problem. We can do a simple Zener diode and resistor dropper to do that, and that should work fine. Don't need to put anything fancy into that. So I've got together some switches which I'm going to mount on the back here for the functionality. If we go back to that circuit, we've got 4 switches really required: pause, next and volume up, previous and volume down, and on and off on there. I'm not particularly worried about the mute. I can just turn it off if I need to, but I may add that later on. I don't know, but at the moment I'm just going to stick with these 4 buttons on here. So let's go back into this and take it apart, and we can see what space we've got to work with. Now it's quite a nice little design actually for a speaker. It's also got a power jack on the back as well, for DC 6 volts in. It's got a little rubber foot there. When I took this apart, I had to slice through that to get it apart, and it's got 4 screws holding the thing together with these little plastic fills that cover up the hole, which is quite nice. Why they did it for that and not for the battery connector, don't know. But anyway, they could have made that battery connector, a little clip would have made it life easier, because you know, if you're going to use this, you're going to change batteries quite often, and having to unscrew it every time you change batteries is a bit of a pain, I would guess. Anyway, so let's get it apart. Let's pop these out. I've already had these out, as you can see. They're a little bit difficult actually to get out, so you have to sort of dig into them to get them out, but they do come out quite easily once you've got them. Screws. I'll whiz through the screws. Okay, that screw doesn't particularly want to come out very easily, but there we are, not to worry. I can simply push it through from the other side. Let's go. Trying to put those screws in. The ones on the battery pack are actually captive, so they've got a little shank on them, so they're captive, so we won't need to worry about losing those. So here we can see 2 speakers, little amplifier. In fact, there's 2 amplifiers, 2 little integrated circuit amplifiers, 1 for each channel. There we are. So there's our power switch, battery power, DC inputs, so there. So that should fit on there quite nicely. In fact, there's plenty of space to do mounting of other stuff. So we should be able to just put a little foam pad or something to mount that on there, and put the 4 switches either side of that. And that should do the job. Right, so what I'm going to do just to give myself a little bit more room to move is I'm going to disconnect the power connection, because I need to also consider the supply voltage. So let's just take that cable off of there. So battery B plus, it shows a little label saying B plus, and that's ground. There we are. So we can take that out of the way. That now gives us room to map out where we're going to put these switches. That must be a little lug from when it was actually moulded, I would guess. So let's just clip that out of the way. See where that went? Oh, there it is. In the bin with that. So I think these are little push button switches. Just push to make, and that's all we need. And if we go back to the circuit, we can see that basically one side of it is all connected to ground, and the others through resistors. Although that one says 0 ohms, the bottom one for the on-off is just a dead short, so we don't need that one. So we've got a 9.1k resistor, a 33k and a 51k. Not having exactly all the right values, I've had to put together just a couple of resistors. I'm just basically going to tag them onto the switches, and that should do the job. So let's get to this and mark out where we're going to put these switches. So I think it might be wise to sort of put two side by side here and here. One there, one there. So if I put them across there, that's going to sit proud near there. So well, we could put 1, 2, 3, 4, couldn't we? Yeah. That'll probably do the job. Okay. Right, we'll just draw a centre line across there. We draw a centre there, and then we can just measure across just to make it reasonably accurate. We just mark them a centimetre apart, right? So one there and one there, and then similarly one there and one there. So that will give us our form marks for our 1, 2, 3, 4. And if necessary, I can always put another switch in the middle, rearrange them. That shouldn't be too difficult. Right, drilling time. Drill selection. Now it needs to be as big as the thread, so on my drill box 7mm looks about right. We drop that in there. Yeah, I think if we put if we make it 7mm, 8mm I think is going to be far too loose. There's a lot of there, but 7mm we can almost screw it in there, so I think we can do that okay. And we'll just have a little 2.5mm pilot to start with. Now, one little thing that I didn't mention, and I should have mentioned in the introduction to this, is that if this works well, I aim to fit another one of these into an old, very good RDS DAB radio, a Roberts radio that I've got, which I really love. It's got a really beautiful sound to it, but it's not got Bluetooth input. So I'm hoping that I can be able to fit one of these and some perhaps slightly smaller switches along the back of it to make it have Bluetooth input. So this is almost like a test run for that, to make sure that the whole thing works. Right, let's get the 7mm drill, open these up. Should have used probably just a drill, a hole opener. Make a right pig's ear of this. Now thinking about it, once that goes through alright, is that going to leave enough space for the next one? Yeah, it is. Let's just turn this just gently. I'm no expert with drills, as you can tell. And what I should have done is probably open this up with a screw, a drill thread opener. Anyway, we've done the job. Let's get a little Stanley knife and just clean up that edge. One, two, yeah, they fit fine. Pop the thread. Get that one out of the way for a minute. Screw it from the other side. Perhaps a slightly fatter pair of right, so we've got one screw in there. I just realised we're not completely in focus there, sorry about that. So I'll get on and do these others, and then you'll probably want to we'll whiz through that bit at high speed. Oh, right. I'm going to do that. I'm going to do that. Right, 4 switches fitted. Not the most elegant of designs. Quite rubbish really, but hey, if it does the job, who am I to argue? Right, we want to connect those 4 together, so we need to bare the bits and pieces, but I don't want it bare all the way across, although I could probably use some kind of other sort of insulating wire. But what I'm going to do is I'm going to clean off about half of that length, like so. Twist, give it a little twist, and clean off a little bit more, but let that pull down to the end, about there. Then another bit, then another bit, and hopefully, if I've got it about right, yeah, not too bad. So that bit's a little bit too far down there. Yeah, that'll do. Give it all a bit of a twist. just tin those bits. Like so. And tin the bottom of each of these switches. Take that one onto there. That one onto there. Across a little bit. Right, so I'll just tag them on for now, and I'll just give them a little bit more solder on. And make sure that end one well, snip that little loose off the end there. So we've got the 4 things there. Now we want to have 4 wires, 4 resistors rather, coming off them. So we've got 8.2 plus 1k, so that's 9.2k. So that's going to be our, let's go back here. So our 9.1k is the previous and next. So if we make that one there, we make this one here the on off, and then the next one being the previous and next, volume down, and then 33, yeah. So we'll put the resistor, the 9.1k, well that's 8.2 plus 1k is 9.2k. It works, I've tested these values, so that definitely works. So we'll put that one next, so we'll just make these resistors into a proper serial connection. Before we do that, let's just clean them off a little bit. What I'm going to do is I'm going to just solder these wires together, these resistors together. So I need to cut a long bit off of that one, into that one. A long bit off of that one. When I've soldered them together, I'm going to put heat shrink sleeving on them. I'm not happy with that solder joint. Give it a little bit of a flood. So yep. A little slight bend in that so I can get it through that. Yep, wrong one. I forgot, didn't I? First one's going to be you know what? I don't like the idea of that because that's going to be very close to the, yeah, even though I'm going to insulate it. Yeah. I just have to make sure they all lay horizontally like that. Right. The next one was 33K, which is that resistor there. So we can snip that off because that's a little tagged on there. Just clean the we've got another one, the next resistor, which is 51K. So here we've got a 18K and a 33K, which is near enough. So let's just snip one end of that off, one end of that off. we get it right with the old clip this time. Oh, that looks nice. Yeah. Bring the end of this off. A little bend to get it through the hook. And then clamp it. Let it go for it set. That's good. I can make use of that one. Goes up to the tag. So the key on here is grey. This little, I guess we can take that. Actually, no, we don't want to do that. We want to leave that on there, don't we? Of course we do. So we need another little piece of wire for the on-off. Those two ends, and that's going to ground, isn't it? A bit of wire. Right, now all these three should all link together. So let's just get some heat shrink on there before we solder it together. Your hot air gun. Lovely jubbly. Okay. I'm just going to hook these together just temporarily. I may want to tidy this all up a bit later on. So let's just hook those together. So, right. So that's going to be our key. We can remove the key wire off my little board. And put that one in. Let's desolder it first, shall we? Right, so that's the key on there. Black, I think, is ground, isn't it? Yep. Let's just disconnect this audio socket. And black is ground, so that can go on there as well. Now, connecting this to this amplifier, we've got on the amplifier, I've not got a circuit diagram for this, but it's fairly simple that we've got two inputs, left and right input. And I was hoping that possibly the socket on here was going to be a switchable socket, so that when it's unplugged it makes a through connection, but it doesn't appear to be that sort. It appears to be just like two inputs. So I'm just going to tack it across the inputs. Not sure which is left and which is right in that respect, but we'll need some power, so let's get some batteries on here. Put the battery cover on for now, just to hold it in place. Okay, so the ground was on there, and that's B plus there. Now, according to the specifications, here's the specifications. You can see it says it takes an operating voltage between 5 volts for the battery version, and 3.7 to 4.2 for the lithium battery powered. So we need to reduce that voltage down to 4.2. So what I'm going to do temporarily is I'm going to use my power supply. I just want to test it. So rather than power the module off of the batteries, I want to before I build a little power connection, I'm just going to take the supply from my bench power supply to do that. So the negative side of the battery goes back over onto here. Let's just have a little bit more solder on that, because we'll need to identify which channel's which as well. So we know which channel is which. Now let's assume that we're listening to it, and we'll say this one, as you're listening to it, we'll say that's the left speaker. Let's just put a left on here and right on there. So we'll power it on. And we should, if we right, that's on. Get no input to it. Okay, let's just check some supplies. 5.4 volts. Just make sure that is just not. Yep. So we should be getting. Maybe when there's no input, the input's grounded, because it does go to ground. Perhaps it is a switching switch. Oh, naughty. Right. Let's get some test sound. In actual fact, if we just plug in we should be able to buzz it, I think. Right. Some test music from YouTube. Okay. It's obviously not quite as sensitive an input as I thought. So let's stop that. And let's use our test signal generator, and we should be able to input a test tone. Right. Well, actually that should be left input from a standard jack. Left is that one, so that should actually be the left. So doesn't really matter. Technically speaking, that should be left, which if you're listening to it, that's what I would term as the right. Okay. Turn that off. Now, can we input, let's go back on there again, can we put that input directly into that amplifier without having to no. We're going to have a jack plug plugged in. Right, so we'll mark that one up as left input. And that one is right. Going by those speakers, that's what I'm going by. So we're left with a little problem then, that when we don't have a jack plugged in, the inputs are grounded by this switch. Okay, right, a little bit of a rethink. The input side goes in here, and this is where it comes out. When we've got a plugged in, it comes out of here and goes to there, but when it's not plugged in, that switching side is shorting that to there. So if I just disconnect this resistor, R8 and R7, I can tag the wires from the Bluetooth adapter straight onto those two, so I don't need to take that socket out of the thing altogether. Now in terms of the power, potentially we've got 6 volts DC from the batteries. Just turn that off for a minute because I was doing some testing. So what I need to do is to drop that DC 5 volts down to something like 4.5, 4.7 volts or thereabouts for the supply to this chip. So I dip into my little box of bits and pieces, and I found myself a nice little 3.9 volt Zener diode. Quick little bit of math calculation with an 18 ohm resistor, that drops down to about 3.9 volts or thereabouts. So I'm just going to hang that across the output of the switch so it's not in circuit all the time. So when the power is on, the normal power goes to the amplifier, and then the power from for the M18 board is connected to there. So I'll just, as I said, I've just hooked it together temporarily and tested it on my power supply, make sure that the diode's okay, because it's a second-hand one, and make sure it's actually doing the job. So I'm just going to hang all that together and see how we go. Right, so let's first off disconnect these two resistors. I wish this didn't fall over all the time. Let's turn it that way. Actually, it's helped us a lot if we turn it over like that. Right, no power's connected to anything, so if I disconnect, just double check actually. Now just suddenly a little think about something. Am I right in thinking that that is shorted to ground? Yeah, it is. So when the jack is in there, it's shorted to ground. When the jack plug is put in there, it's not shorted to ground, so therefore that shouldn't beep. Yeah, right, so I was right. Just triple checking what I was thinking. Okay, let's just disconnect these two wires. Actually, it might be easier to... No, let's disconnect the resistors. Hook the wires on the resistors on the other side. Go on. One resistor, two resistors. So at the moment this is all just hanging together just purely for testing purposes. So let's put the plus B back on the amplifier, which goes on there. A bit more solder. Try again. So plus B on there. And resistor. We're just going to tag the resistor onto that same plus B line there. So we've got plenty of circuit to work with. Yep, that's right. And then just bring that round and tag the bottom end of the Zener diode onto ground just there. And then we take the plus B feed. This might ping the two apart with the heat. Let's just tag that on there. So we should now have the right supply voltage for that. And then we can just tag the two outputs. These two resistors. Right, so a quick triple check. Plus B feeding there, plus B feeds the resistor, feeds the Zener diode, that supplies down to there. So we'll put our meter on there. I'll make a nice easy. Oh no, that's going to supply, isn't it? We want the ground. That's going to be ground. And we shouldn't be having any supply on there at the moment, which we haven't got. So we turn it on. And we got 1 volt. Why have we only got 1 volt coming up? Odd. Okay, let's just disconnect that resistor for a minute, just in case. I shouldn't be dragging it down to 1 volt supply. Back on here, still only got 1 volt. Meter is okay. Connected in the right place. Why have we only got 1 volt? Oh, is that? Yeah, that's ground and that's ground, but I haven't connected the ground. No, that's why. Really silly. I haven't connected the ground side of things, that's why it's not reading anything. Take that back onto there. Take that onto there. Now we can connect a ground between there and the actual power ground, which is that one. That's what we haven't done. So let's get ourselves a bit of black wire so we know everything is the right colour. Right. Try again. That should now be a definite ground. That should definitely be supply, which we have 5.6 volts. So we turn that on. I heard a little, yeah, and I heard the little tone for the Bluetooth. 4.4 volts across there, and the Bluetooth module is working. Cool, we're nearly there. Let's get my phone. Let's find some music to play. Right. Okay, this is the music that I use for my opening. So now if we go on to Bluetooth, turn Bluetooth on. And there's our device. Yay! different stuff. So the volume plus is our 33k resistor. You know, I can't remember which one's which now. I think that's the 33k. Yep. That's volume down. It's good, isn't it? So that one should be pause. That's off. That's on. Yeah, for some reason the pause button's not working. Let's make sure it's not a faulty switch. Let's short it out. Oh, perhaps I got those resistors wrong. I'm pretty sure I did test it. Well, it may not be the best. It may not be the best device in the world, but at least it's working, and I'm quite pleased with that. So all I've got to do now is to tidy up all the wiring, etc. Fit it all back in the box and see if I can, sort out that little problem with that pause button. I have to cut off the heat shrink that I've put onto that resistor there and find out why it isn't connected, unless it may just be a bad solder joint, but I doubt it very much. That little resistor there, not getting hot, dropping that voltage, but it's obviously enough voltage for that Bluetooth device to work. The other thing I've got to sort out is this socket. Now, as it is a switching socket, what I might be tempted to do is just cut round that, if I just bring you in here, what I might be tempted to do is to just cut round that little bit of the circuit board there, so that this switch, when the jack plug is out, make that switch the input from the Bluetooth, and then when the plug is plugged in, it goes to that one, so that when it's not got anything plugged in here, the output goes from the Bluetooth into there. Yeah, so if I connect the Bluetooth to that one when these two, when they're not connected to ground, when there's no jack plugged in, it will connect to there, through that connector, through the resistor. So that, yeah, that's it. That's the way to do it. So that'll save having to try and find another socket or whatever. Okay. I've got to go and do some other bits and pieces, and it's probably going to be a lot of fiddly stuff I'm not going to be able to get on camera properly, but the whole basic principle of it is there. So I'm going to come back to this when I've actually done all the tidying up, before I wrap it all up and sort out that resistor as well. Okay, so see you after that. Right, well, I've done my bit of tidying up and fault finding, and basically what I did on this circuit board, if I come into here quite closely, what I did was to cut this bit of the circuit board across here and across the middle, so isolate these two connections, wire the output from the Bluetooth directly to that, so that when there's no jack plugged in, the Bluetooth goes to the two channels through there. When the jack plug is plugged in, then that overrides the Bluetooth, so that we get maintenance with that jack going straight in there. tidied up the wiring a little bit. I checked this resistor, and the resistor that should be 51k and is exactly 50.99k. The makeup of the resistors that I'd added together. Still couldn't understand why it wasn't working, because it did before, but then I realized that the player I was testing with earlier on was a player from my phone, which is part of another bit of an app. If I use the one I usually use, which is VLC, then that function does in fact work. So now it's connected, so I can show you that if I press the pause, it starts again and stops, and the volume goes up and down as it should do. Now the volume up and down should also do next and previous tracks, but for some reason that isn't necessarily working either. The previous one just stops it and starts it again. It doesn't, if I press it multiple times, it won't go back. It's probably to do with the way that the Bluetooth connectivity is with this phone. It might work better with a different app, but the point is all the connections are working. So all I've got to do now is basically put it back together, making sure that everything fits correctly. And basically what I'm going to do with this Bluetooth is I'm just going to use a bit of double-sided tape and stick it down into there. The dropper resistor and Zener diode for the supply for the Bluetooth, I just basically tag that into the switch there and to the ground there. It's very convenient just to pop it down there out of the way. Those are going to bend down there out of the way, so they won't make any connection with anything. So it's pretty much done. So let me just switch it off and put it back together, and hopefully everything should be going back together as normal. So let's just mount that onto there, just double check that nothing is going to be shorting out. Yeah, those wires I've insulated, they're all fine down there, so we can pop the little mounting screws back in there. And there should be enough flexibility in the wiring for that Bluetooth module to just quite happily sit. Might as well mount it on the side with a bit of double-sided tape. Put that on there. Let's cut that little bit of excess off. So just a little bit of Bluetooth, bit of, I was going to say blue tack for a minute, bit of double-sided tape. Actually it will mount on the flat side of those batteries there quite happily. There you go. And we pop it back together. And there we have one Bluetooth sound bomb. Now the only other thing that I didn't do that I was going to do, but it doesn't really matter because I don't really need it, and that is to hardwire out that Bluetooth LED. But the point is, as soon as you switch it on, that sound indicates that it's started up. That second sound indicates that it's connected. So we can go back to media player, press play. Volume down, volume up. Pause, and green for off, green again for on. Just reconnect, there it is. Play again. And if we want ordinary sound in there from something else, it's playing back from a little mini disc player. Job done. quite pleased with that. It's worked well. So hope you've enjoyed that little foray into modifying a sound bomb for Bluetooth connectivity. It shows it's fairly simple to do. Just a case of doing a little bit of planning, working out where you're going to put things, testing it before you put it together, tacking it together to make sure it's working part way through, rather than going all the way through, wiring it all in and find it doesn't work. So if you tack it together, you can do fault finding quite easily. So that's basically going to be that one for that one is completed, and hopefully I shall get on and do, as I said, a Roberts radio. It's going to be a little bit more complicated because that hasn't got an external audio input, so it's only got audio outputs. It may possibly have potential for an audio input that's never been used. I might be able to find that in the circuit diagram if I can get a circuit for it. Roberts are pretty good at that though. If not, I may have to do some reworking of the circuitry to add in a socket, a switchable socket, so I may have to buy a socket as well, sort of thing. But anyway, hopefully I will get to that fairly soon. Thanks very much for watching. Hope you've enjoyed this. Do sign up for the channel if you haven't already subscribed. It's always nice to know that people are following you, and thanks to everybody that's been commenting and sending such nice comments onto the channel for the things that I've been doing to try and just give you that little bit of help and a little bit of knowledge that I've gleaned over the past 50 odd years doing this sort of repairs and stuff. So thanks again. Cheerio.